Hi, my name is Ives Winnicke. I'm majoring in computer science and Russian, and today I'd like to talk about my honors thesis, automatic key phrase extraction from Russian language scholarly papers in computational linguistics. Let's just jump into it. The motivation for this project is that I'm a researcher, an aspiring researcher, and I'm not familiar with all of the research areas and technical terminology for a scientific community, such as the cross-disciplinary and cross-linguistic field of Russian natural language processing. So this project uses automatic key phrase extraction to build a back of the word index or a glossary of the technical terminology for the main topics and the main key phrases and words used in this community. The research question is, what are the salient key phrases for Russian papers published in the Dialogue Journal? Now, it's important to note that techniques for automatic key phrase extraction are really dependent on the context. Is it audio? Is it text? Formal? Informal? Russian, English, but a lot of the automatic key phrase extraction implementations are adapted towards English text rather than Russian text. So the goal for this project is to create a proof of concept, a free and open source program for automatic key phrase extraction from Russian scholarly papers. Now, this is inspired by topic clustering approaches for automatic key phrase extraction. And in this project, I use some of the techniques of previous research of the same data set, the same corpus. But the previous research focused only on English papers, where I'm focusing only on Russian papers. The researchers from that previous work later published their code for pre-processing Russian text, so I'll be using that pre-processing technique. And I'm basically doing a topic modeling based approach towards key phrase extraction. Before we talk about automatic key phrase extraction, let's talk about the corpus. What is the data that we're working with? What is the context? So the data is the Dialogue, which is the largest and oldest international conference on computational linguistics and intellectual technology in Russia. They've been doing this every single year since 2000. We're working with scholarly text, which typically is in a PDF format, and the structure of the text is predictable. There's like a title, abstract, maybe keywords, might be an introduction, references section, and we're working with Russian text rather than English. So Russian has a rich morphology. If we look at this picture down below here, then we can see the variants for English are very different from Russian. Russian has a lot of variants depending on the inflectional and the derivational variants that there could be for a single word. We have to deal with this. Next, how do we do automatic key phrase extraction? So there are typically two steps. First one, extract candidates that could be our key phrases. And then the second step would be rank those candidates and pick the top most likely candidates. In this first step, we create the corpus. We extract the documents, we download them to our computer, extract the text, and only look at the Russian text. Then we clean the text, so any corrupt data, we throw away. Any irrelevant data, we throw away. Relevance, or the references section, is irrelevant. Tokenization, so we break down the text into small key phrase size chunks. Now these might be words, these might be acronyms, these might be sequences of like 2 or 3 words. Then lemmatization, basically get all those variants for a single key phrase token, and we shrink them down to what you might find in just like a dictionary. Stop word removal, we remove really frequent words that are obviously not keywords, like the, a, because, and frequency thresholding. So we remove extremely rare tokens that are probably mistakes and extremely frequent tokens that aren't really specific enough for being key phrases. Ranking candidate key phrases, there are a lot of different approaches. In our case, we use topic modeling, in particular LDA. I'll talk about that a little bit later. So step 1, pre-processing. Over to the right, we have an example of 2 sentences in a Russian text. So I know this is in Russian, so it might not be understandable for everyone, but if we look at the before and then we look at the after, we see that we have these bite-sized candidate key phrase tokens. These are chunks that could be like 2 words, or they might be like 1 word. And there are certain words that don't appear. So really frequent stop words like v and e, and any like in-text citations or anything in parentheses or in brackets, they're not included over here. Any punctuations not included as well. So then after we pre-process the text, then we could use our topic modeling approach. So This is latent Dirichlet allocation. This is a bit complex, but it's basically machine learning. It uses probability in order to basically determine what are the topics, like the research areas, and the candidate key phrases in a text. So basically, the intuition is like this. We have this text over here, and the black text is basically not important to us. We're looking just at the colored text over here. And we assume under LDA, under topic modeling, that this text is composed of some number of topics. In this case, we have 4: arts, budgets, children, and education. And then we assume that for each of these candidate key phrases, each of these significant words over here, that they can be partitioned into one or multiple of these topics. So this will form like our research areas. In this case, we maybe have 4 research areas, and the candidate key phrases that basically give us an idea of what that topic is. So like budgets is tax and budget, billion. Children might be people and families, so on and so forth. Next, after we train our LDA model, then we can take it one step further by using PyLDA this. So this is, I switch tabs. This is an interactive visualization technique, typically not used for key phrase extraction, but in this research, we're using it for ranking. And basically, we have 2 things going on over here. Over to the left, we have our topics. So in this case, we have 5 topics. And topic 1 is relatively different to topic 3 compared to like topic 2 and 3. They're very close in semantic space. Also, topic 3 is fairly larger. Over here, we see it's about 42% of the tokens, whereas topic 1 is a lot smaller, about 9%. And if we look over to the right over here, we have our key phrase, candidate key phrase list, and they're ranked based on this relevancy metrics. So by default, LDA puts it to 1, which is basically the most probable key phrases for a topic. If we put it to 0, then these are our salient key phrases. So these are key phrases that are a bit more rare and more exclusive to this topic and none of the other topics. The creators of this visualization show that if we put it to 6, 0.6, then it's the easiest set of key phrases for us as humans to understand what the topic is about. Go back to this presentation over here. Then we can look at the results. But before we look at that, let's return to our research question. What are the salient key phrases for Russian papers published in the Dialogue Journal? Now we have a table. A lot going on over here. Let's break it down. We have 5 topics, latent topics, and then we have the size of those topics. And then we have a Russian version and an English version. Let's look at the English version. So for the English version, we have lambda the relevancy set to 0.6 to give us an idea of what the topic is. And then we have lambda set to 0, relevancy is 0 for our salient key phrases for that topic. Now, if we look at topic number 3, we can see that it's a fairly large percent. It's a fairly large topic. We look at the key phrases, then we see that, these are words that are not really common in Russian in general, but they're not really specific towards a research area. So these might be terminology that's specific towards scientific text or towards computational linguistics for this journal. If we look at the other topics, however, they're a bit more specific. So this first one, we have discourse, communication, verbal, might be more of like discourse or communication. Second one, we have express, movement, interpretation, semantic. That's a bit more of like semantics and word sense. And then the 4th topic, we have query, document, search, learning. That's a bit more like information retrieval. And then this last one, algorithm, classifier, tag, module. Those are very clearly computer science, machine learning terms. So if we look towards future work, there's a lot of areas for improvement. First of all, we can improve the pre-processing by using layout-aware text extraction, basically only extracting text from like the title and the conclusion or introduction. And by doing that, we can remove a lot of irrelevant text that might lead to language misclassification. English papers that have a lot of Russian examples are misclassified as Russian papers, unfortunately. And that is errors later on. So we can also improve the pre-processing of Russian text, use better lemmatization, and we can also implement better, more sophisticated state-of-the-art approaches towards key phrase extraction for Russian scholarly text. For conclusion, we found that the salient key phrases in the Dialogue Journal typically cluster around like 4 areas: discourse communication, semantics and word sense, information retrieval, machine learning. And this project used a topic modeling based approach to automatic extraction of key phrases with a proof of concept with LDA and PyLDA-vis. And in the future, we could use in more sophisticated techniques for better results. So that's it for my presentation. I hope you enjoyed and I hope you learned something. Thank you.